This conference will now be recorded.
Okay, so welcome to our Clean Network teleconference today. I will start by asking if there are any announcements.
This is Jen Kretzer from the Wild Center. Hi, everybody.
Hi, Jen.
Hi. I just wanted to say that this week we have our New York City Youth Climate Summit that's been organized by the New York City Department of Education Office of Sustainability. It's being held in downtown Manhattan. I think they are fully subscribed with over 150 students from across the 5 boroughs attending, and so we're super excited. I'm heading down on Thursday to support, and we're just excited to see this happening. So,
and who is it in partnership again with?
It's in partnership with the New York City Department of Education Office of Sustainability. So New York City serves the public school system. It's 1.1 million students and about 90,000 teachers. So this is like, the teeny drop in the bucket kind of thing, but it is being organized. They have an Office of Sustainability, which is I think around like 15 to 20 staff that operate full time on sustainability issues for the city. The exciting thing about this summit, like we have the mayor's office is going to be there, and they're actually facilitating a workshop. So, we have the UN representative from the UN Environment Program will be there. So there's actually some really great participants, and they had a group of youth leaders that helped plan the summit, similar to what we've done with ours and what we encourage other sites to do. So we're really excited to see it come into play, and even more excited about what it might be a catalyst for in the future.
Oh, great. Well, congratulations. So this is just starting this week?
Yeah, it's just one day. It's just on Friday.
Okay.
Yeah.
So, good luck.
Yes, thank you. That's my announcement. Thanks.
Any other announcements?
Yeah,
Jim,
this is Kate.
Go ahead, please.
Okay,
Jim,
thanks,
why don't
Jim.
you go first?
Yeah, Jim, go first. That's fine.
Oh, well, this is actually more just like a comment, which I hope is even strengthening what you're saying, Jen. Is there's the thing of when you have leaders, you want followers, or you want to show that you're not doing something that can only be done in one area. That the wonderful things you're doing in New York, and that cities and school districts and states and their programs are wanting to move ahead, right? We're moving ahead. That's happening in New York in wonderful ways, and I think take pride in if there's ways to connect up with what's going on in California. We know Maryland, Washington D.C. Those are areas where it is likewise happening. I mean, that's not to diminish what you're saying about New York. It's that you are very much a leader in a movement where I think the states and the cities are not waiting around for the federal government.
Right, and I think that the fact that they're not going to wait around, like that's where we're going to see work happening right now. I mean, we all know this, so it's not like it's anything new, but this is where it's happening. It's happening at the local, regional, and state level, and certainly won't happen at the federal level for at least a while.
Yes.
Yeah, and related to that, I just saw this morning that Connecticut has proposed legislation to require the teaching of climate change. Which standalone from the standards, specifically a bill that says schools must teach about climate change, which I think is kind of cool.
Great. Okay, other announcements?
Yeah, this is Katie Boyd. I just wanted to let people know we had a change in schedule. Somebody who is supposed to present next week can no longer do it next week, and we've rescheduled her into March. But if somebody had something that they wanted to try to put together in the next week to present, we have an opening. So just wanted to throw that out there in case anybody wanted to contact me to you can just send me an email if you want to get on the schedule for next week, because there's an opening. Thank you.
Okay, great, thanks.
Yeah. And this is Anna Gold. I just wanted to mention I got on a minute or so late. I don't know if anyone mentioned the ESEP meeting is going on right now, and Patrick Chandler, our ESIP fellow, is there, and he's presenting on clean, giving a poster. And I think Frank Niepold as a citizen is there also.
I think he didn't end up going because he told me that he couldn't register because he was going to do it through his NOAA. I think he decided not to go as a personal thing, but I could be wrong. Yeah.
But Patrick Chandler is there and representing Clean, and presented a poster that Katie put together.
Oh, great. Very good. Thanks. Any other announcements? Okay, then if not, then we'll move on to our presentation for today. We have Ingrid Zabel and Don Haas from the Paleontological Research Institute Museum of the Earth. Ingrid is the Climate Change Education Manager at PRI and leads climate change science activities with youth and the public at the Cayunga Nature Center, and at the Museum of the Earth, and at schools in Ithaca, New York, and New York City. Don is a director of teacher programs at PRI and its Museum of the Earth and Cayunga Nature Center, and he is the past president of NADT. And as you've heard on these calls multiple times, Don and Ingrid have both were co-authors of the Teacher-Friendly Guide to Climate Change. And they're going to talk to us today about a climate and energy exhibit at the Museum of the Earth that they're revising and want input from us on. So with that, I'll turn it over to Don and Ingrid.
Thanks. All right, thank you. So yeah, this is a little bit different than presentations we've given in the past. That is, we're not going to be reporting about some project that we've completed, but rather we're in the middle of a project and we're looking for some input from people. We are building a new exhibit on climate and energy in the Museum of the Earth. This is to replace an existing exhibit, and I've taken a picture here. It's kind of a crude mosaic of photos from my cell phone, but it's kind of a long, horizontal rectangular wall that we have to work with. I showed on the left, you see there's a door, a gray door that goes to kind of a utility space in the back, a boiler room. But I included it because we have some ideas of maybe how to use those doors as part of the exhibit, so I wanted you to see that. If you've never been to the Museum of the Earth, it's a natural history museum, and it tells the story of life on Earth. And as visitors come, they walk through chronologically. So they start out at early times and then move forward to the present. And this space where the wall is kind of an interesting one because visitors will come here both as they enter the main part of this museum and as they leave. So kind of coming in at early times and leaving it at the present. So that's something that we have to think about in designing what goes on that wall. All right, so we are not going to share with you the whole outline of all of the content of the exhibit, but rather we've picked out a few pieces of content, ideas for interactives or visuals that we want to sort of test or get your feedback on. What you see is going to be kind of crude, sort of in sketch form, so don't worry about the aesthetics at this point. We're just working on ideas. Any questions to this point?
Just one. So can you have the picture here. From which side are people going to enter?
From the left. So people come into the museum, they come down a ramp. This is actually at a bottom floor, and where it's sort of bright white to the very left of this picture, that's where they come in.
Okay, I just wanted the context for going forward, so go ahead.
That is where they come in, but then they sort of go to the opposite wall and go along the opposite wall and come back out this way. So they first see it as on the side with the doors, but we kind of would like them to pretend they don't see it. Experience it, pay attention to it on their way out of the museum, because this is modern times, and across the hall is the Precambrian theater, and onward.
I see.
Present from across the hall.
Mm-hmm. So
Okay.
as they exit, they'll be walking from the right to left in this photograph.
Okay.
All right, so the first element that we wanted to ask you about is a graph of carbon dioxide and Earth's surface temperature going back 800,000 years. So many of you, I'm sure, have seen this. This is from the ice core record, and then at the present, appending on the Keeling curve for CO2. And I'm going to ask you to just take, I'll be silent and give you about 10, 20 seconds to look at this, and then on the next slide, we have some questions about it. Oh, and I should say, don't worry about, for instance, on the axes, I haven't put units of CO2 and temperature, and obviously we would add those things, but don't worry about those little details right now. All right. So our first questions are, as you look at that graph, what do you think of the direction of time on the horizontal axis? Does it matter to you if the 0 of time is on the left or the right?
This is Tamara. I actually looked at your Prezi presentation, and that was what first thing I thought about, was because while it shouldn't matter, most people are used to time going the other way. And so the question is, what will visitors, I mean, I as a scientist would look at the axes and which direction time is going, but a lot of people won't. So that is something to think about.
Okay.
Yeah, this is Katie Boyd. I had sort of a similar reaction. Like my first instinct was, oh, that's different, than what I'm used to, or backwards from what I would assume or think of at first. But when I looked at it, I do know I've seen, like, in paleo climate research, I've seen graphs that do move that way or have that sort of axis. So that's sort of what I thought about was, oh, maybe that's just the standard for this field or something like that. So yeah, my initial instinct was sort of like that seemed wrong, but I thought once I thought about it a little bit more, it was like, oh, that maybe isn't an issue. I don't know.
And I don't know if you want to bring in the future possibilities here, but then that vertical axis at now implies an end, and that time will continue on to the left here, whereas you don't have that vertical line on the right side usually. I mean, sometimes you have axes on the right side, but in this particular case you would. So it does imply that nothing happens after now, 0.
Mm-hmm.
This is Wendy. My immediate thought was that the less common presentation with now on the left sounded like it was in keeping with your entire museum floor experience of moving from the past to the future. And so it felt like it was the end of that story by presenting it that way. And I thought that was a little interesting enough. It kind of makes it compelling as long as you make that now really, really obvious. It could work.
Mm-hmm. Okay.
Was there a reason that you're doing it? Did you have a compelling, interesting reason for doing it this way rather than the other?
It's exactly the reason that was just stated, that we're thinking about the flow of the way people walk through the museum chronologically.
Mm-hmm. Okay.
Sense this way. I should also mention about Tamara, about your comment. I left out here at the top of the of this line, we are planning to have an arrow and actually going up to the ceiling and sort of implying time goes on.
Yeah, and actually we have talked about and hope to be able to afford it, not only going up to the ceiling, but putting artwork in the ceiling that makes it look like it goes through the ceiling, and having as a sculpture on the patio above this space, which we think
This is Jim. I think that, this is okay. The now is very prominent, but I would caution that if you are intending to use other graphs of this sort, that they be consistent in terms of the direction of time.
Mm-hmm.
Yeah, and if we didn't say it, the reason that we reverse that is to keep with the flow of the rest of the museum, so that you're walking to the present as you go, you walk through the museum in the way that we hope we sort of direct people to go through the museum. And so the end point of their museum experience should be at the line for now. And we have also talked about allowing enough space to add years, leaving 10 years worth of space to continue the graph as time marches forward in the next 10 years.
Yeah, but, so how long is this? I mean, will there be, given that the scale is 800,000 years, going into the future might not be really visible. I mean, I'm not really sure how big you're planning to make this.
Yeah. And we've talked about
The future. Yeah.
the future is up. And we'll have an expanded section that we'll talk about in a little bit for the last 150 years or so.
I see. Okay.
So,
Yeah.
So I have a comment, Jim Callahan, a question with kind of also, it's a comment with questions. Is in the format of presentation, the way in which we present at a science center or museum in this case, having looked at what other science centers and museums have done across the country, have they done something similar, and how did it go? So that's kind of my question. There are many different science centers who have done things many different ways. Museums all across the country, probably dozens of them. The one where I know that this has been specifically done before, is at the Cal Academy of Sciences in San Francisco.
Yeah.
Now, it was not this particular graph, but it was the idea of making a graph that we might typically see in a magazine or on a data on the web, or some other way that science is being presented in graphs, but make it really big and put it on a wall and have it, like you're saying, like go through the roof. Right? They had like Al Gore's way in which he got up on the scissor lift and went up to point out how high it went. That was his dramatic way of saying, look at the hockey puck. Now, it was a hockey puck, but it was also a graph. And they did this in a much bigger way than you even have the space for. So there would be the one of, so I'm going to keep it as a question without trying to give you what happened, but how did that go at places like Cal Academy of Sciences? How did the public receive it?
Yeah, that's a good question.
Another thing you might think about, I was thinking about doing something on the floor, and the simplest thing would be to have the x-axis lines, the 800,000 year line, the 700, and so that as people walk, they're crossing those lines physically.
That's a good idea. I like that.
Yeah. Okay.
Alexandra Moore is sitting with us, and she pulled up the original article where the ice core data was published, and it had the graph oriented this way, which I didn't know until 2 minutes ago.
So let me move on to another question about this graph.
Before you do, this is Frank Granshaw.
Sure.
Hi, Frank.
A quick question there. If you could go back to the particular graph.
Yeah.
What I'm wondering about is, as a little help for folks, if that now could actually be moved above the blue line for CO2, arrows put to either side and put past and future.
I'm not sure I understand the arrows. I get them moving it up. Oh, okay.
Arrows pointing,
pointing left and right.
forwards.
Yeah. Okay.
Yep. Pointing to telling people what's past, what's future on this graph.
Right. I see. Yeah. Okay.
Mm-hmm.
That's a good idea. Past, future. Okay, I'm writing this down.
Okay.
Okay.
So you can just talk.
Okay. So I'm going to move on. Another question. This is a picture, actually, of another example of such a line from the Birch Aquarium at Scripps, and they have a big graph going across the wall. Theirs, you can see, sticks out from the wall a little bit, maybe a few inches. And so we've been thinking about this. Could we make our graph three-dimensional on the wall as opposed to having it two-dimensional painted or printed on the wall? And I guess our question to you is, looking at that and then, or imagining it just flat in 2D, do you think having it 3D is much more compelling than 2D, or do you think it doesn't matter? And of course, there's a cost issue, right? It would certainly cost a lot more to make it 3D and make it stable, so when kids pull on it, it doesn't fall off the wall and so on. But what are your thoughts about this question?
I do like the 3D. What I'm struggling with was how important is it for helping people really engage with it.
Yeah,
Whether it's
this is Wendy. I feel like we're in a way the wrong audience answered that question, because a scientist certainly doesn't think about needing data presented this way, but we're trying to reach people that might not look at as many graphs as we do.
Yeah. Right, but you're also a human being who goes to museums. You think things look cool or they don't, or, you know, but aside from being a scientist, or, you know.
Yeah. I think having it 3D will draw people to look at it more carefully. So I think I'm tending to default on the side of liking the 3D, but I understand, I don't know what the order of magnitude cost change is.
Mm-hmm. So here's a
this
thought.
Is Jim.
Go on ahead.
I don't know if this is a consideration, but the 3D looks like it would be something that would be helpful for the visually handicapped.
Mm. Yeah, that's true.
Yeah.
As long as it's reachable.
Yeah, it would be.
So, Jim Callahan, again, let's see, comments from experience with science centers, museums, and yes, aquariums. Here would be a thing where both the Birch Aquarium, as you're pointing out, and the Cal Academy of Sciences did have in the background a very large graph, maybe a different graph, but the same. It was a very prominent bit of the thing. One exhibit, the Birch Aquarium, was very successful, very well regarded. People loved it. There were a lot of things to do. There was a lot of interaction. There was a lot that was something that was special, that was something that you couldn't get somewhere else or on the internet. And the Cal Academy had just a few things to look at, but most of it was words on walls and graphs. And theirs was universally regarded as a flop. They regarded it as a flop. The newspapers regarded it as a flop. The public regarded it as a flop. It was it never went anywhere. And
like our current.
It was the thing, if the difference was not the graph. They both had graphs, but there was something else that was going on in the entirety of the space, that one was very successful and one was the graph.
What was the difference?
It was what else was going on. The graph, I don't think, had very much. They both had big graphs. But one was a flop and one was a success. The graphs weren't that much different.
Yeah. What was different about what was going on in the space?
Okay, so at the Birch Aquarium, there were games, there was interaction, there was live animals, there was tying into their aquarium, right? I mean, now you're not going to do an aquarium, you would do paleontology, but they're engaging the public. The public is part of the learning. They are exploring. They aren't just witnessing data that's being presented to them, because they can do that at home. They can do that some other way. It was something that made this place special. It also made it social, that you, even at home, if you have a game, to do it with 20 other people, or have a school and a whole classroom be able to engage in the science or the solutions. Birch Aquarium was alive and full of things to do. Both of them had graphs. The Cal Academy, there was nothing really to do.
So this is Frank Granshaw. One thing I want to ask here, is there a way to raise a hand on the Co2 meeting, or just blurt, or just do I need to just blurt in? I'm trying to figure out a way to work that.
I think blurt away.
Yeah, I think just go ahead and talk when you can. I don't think Co2 has that, but I'll look into it. Thanks for asking.
Yeah. I'm going to look at this from the point of view of construction, because I actually, before teaching college, I did 10 years working in science museums, including in some cases building prototypes. And so I'm looking at this from the point of view of, I think the 3D makes a lot of sense, because it's going to be much more attractive to people than just simply something painted on a wall. And I think Jim made the comment in terms of the 3D aspect being good for people who are blind, being able to actually feel the ups and downs on that. And that's good even for sighted folks. Mm-hmm. But one of the things I'm wondering here is I'm looking at this from the point of view of the Birch Aquarium is kind of a fence that sticks out from the wall, basically, and that's not very durable. And I'm almost wondering if you maybe could do, well, if I was going to build this, I'd essentially take a sheet of 1-inch plywood and cut it on the top to match the graph and then put that on the wall. So the entire graph from the floor up to the graph itself comes out of the wall.
Yeah.
Hmm.
Yeah, that's kind of what I'm thinking too. Yeah.
Mm-hmm. Okay.
A similar one would, do you have anything in mind, as some can do, where people can engage in what CO2 levels are like? I mean, for instance, a very simple thing to do. So, I mean, what is CO2? And make it real and make that its influence and things. A simple starter is that you have a CO2 monitor in which people can take the air from outside, the inside, and if they breathe into it. So they can see that CO2 levels can go up and down tremendously just by, say, human breath or by plants, or what is driving these CO2 levels up and down. Of course, there's temperature, but temperature is then driving something else that happens that makes the CO2 happen. But that's something that you could give people that they will not get on the internet or somewhere else, is some experience with carbon dioxide, something they can experience. I bring up the breathing because people do love to make a bridge between themselves and their own experience and the science that you're doing. You provide that bridge.
Right. We did have that in an early iteration of our outline, and then we dropped it for some technical reasons, but it's worth reconsidering. Yeah, I like that idea of people engaging with it. Of course, this is only one part of the exhibit. We have other sections where people will be engaging with other things, but that's an interesting thought of how can they engage with the timeline, either with temperature or CO2.
You know, one thing that this Frank again, and one of the things I'm wondering about is taking that notion of interaction a little further. I'm imagining that what would make this a little bit more tangible for the visitor is the question, what would the world be like if CO2 was at this level or at this level or at this level? And why is it at those different levels? I don't know how, I mean, short of putting a computer kiosk next to it where people can sort of dial into different parts of the graph, I'm not sure how you could interact with that question, but I think it's an important one.
Yeah, that's a neat idea. Well, any other comments before I move on to the next section? All right, I think I'll move on. So the next one is actually another graph, but I'll show you our exhibit is not all graphs. We just happen to be asking you about some graphs. But this is sort of the same thing, but zoomed in on much more recent past, just the last roughly 150 years. And we have, we're looking at 3 different ways to visualize this, and we want to get your opinions about them. So one way to visualize this is this graph that you've probably seen, you know, a line graph or a scatter point graph, temperature over time. The next is this visualization, which you may have also seen using color to show temperature. And we could put in a scale also showing, you know, the exact temperatures those colors correspond to. I just haven't here. And the third is a combination of the two. So I can show them again, or you can just give us your initial gut reaction.
This is Anna Gold. I think I connected the best with the last one. I found the middle one very hard to read. I've never seen a graph in that format, but that's probably just me. I have another comment, though, that I wonder if temperature anomaly is too jargony.
Yeah.
And also if maybe degree C is not as meaningful. It's maybe different from today, or, you know, something else. Or maybe put it in Fahrenheit and you could put, you know, Celsius. I know, Katie, you know better, having been in the museum for a long time. Do you put both?
Yeah, I think we would probably, this is just a sort of a placeholder for now, but I think you're right that temperature anomaly is, people aren't going to know what that means.
Yeah, I was going to
Right, the graph will look the same, even if you Yeah, I think you should use just the temperature and not the anomaly, but then start it at a low level so that the x-axis isn't 0. Just so that you have a sense that temperature can go negative too. That's just a nuance. I do, but in terms of the 3 visualizations, I like this one the best because it does both align for those. I mean, people just learn and understand things in different ways, and I think it's more powerful with the colors and the line. I agree with Anna. I had to sort of look at the color spectrum for a minute to make sense out of it. So I do like this one the best.
This is Wendy. I am familiar with the middle presentation. It came out of the broadcast meteorology realm, really promoting that after that work, and it was a big success. It got people talking about climate change, but I've never seen it presented this third way. And with the other comments about maybe not focusing on the anomaly piece, I think the third is very powerful. I like it.
Okay.
Yeah,
Oh,
I sort of agreed. I thought the third, I've seen the second one as well, when that's been going around a bit more lately. I feel like on the internet, sometimes I see it more often than like in papers or anything. So, but I actually really like here that you've put it under the graph so that you can get a sense of what, like, I agree when I just saw the colors themselves, it was a little harder to, even for me, having seen it and knowing what it was, this was actually easier to then visualize sort of how that actually works out. And I agree with the comments about the anomaly, and that, I don't think that you don't have to call it anomaly, but at least say what that is somewhere, but I overall, I think that, yeah, that's sort of a jargon term that maybe could be tried to avoid. I don't think that the concept is too hard for people to get, but I do think you have to kind of explain it to them for them to really interpret this graph correctly. So it might be easier to just sort of make it more simple.
I think that all these comments are great. I'm just trying to actually wrap my head around this graph, and I wonder if if this is actually maybe not the best way to depict it. I wonder if you have to have the colors, if you have to have a line at 0 and then have the colors bars go up from 0 to 1 at the very left, because right now it looks they all start at a random minus dot, and that's not what you are saying. Does that make sense? And then in the negative ones, you would actually not fill the bottom one, you would fill the top one, going down from the middle line. Maybe, am I making sense?
That's a good point.
This is Jim Bray. I also have a concern about the color ramping there. I think that the neutral color white should probably be associated with 0, and the blues down from that, and the reds up from that. It would be a cartographic convention if you were doing a map.
Well, that's if you stick with the anomaly.
Right.
You don't want to do that if you're just starting. If you just have temperature, then that applies something magical about 0.
Right.
I'm looking at 3.
Yeah, I don't think you could do just temperature as well with the colors. I mean, you could still, but from what I've seen of this visualization from the colors, not the graph part of it, but the colors part of it, is to really highlight the anomaly aspect, because that's where you get the like really red at the end and blue at the beginning. That helps with that visualization of it.
Could this may be more? Let me just voice this thing, because it might just make things more confusing. But if you had the line graph be temperature, but then the colors be anomalies, would that just make it really more complicated to understand?
Yeah, I don't know.
Yeah. This is Frank. I like the third graph. I think the idea of starting all the colors from 0 up to the top makes a lot of sense. I'm also looking at this from the point of view that the anomaly piece, it would be nice if there's another word we could use, because what it's saying is something that strikes me as pretty critical to the fact that everything that UNFCCC does right now, everything being talked about in the conferences, is in regards to that anomaly above industrial levels.
Yeah.
Mm-hmm.
Yeah, and I think we can nuance the language, and you know, we welcome feedback on that. I don't know, you know, folks can send us, certainly anyone who has ideas about any of this stuff can send us emails, and I think that we can come up with, we can preserve the idea of anomaly without having the word be the big prominent thing it is now.
Yeah.
You know, departure from average or something like that.
Mm-hmm.
Jim Callahan, a couple of things of when we've historically done temperature, and our organization back 20 years ago didn't have a lot of money and was trying to keep it simple. So we know this works simple. Is again, there's a way that people give people the ability to manipulate the possibilities, or maybe make their own projections and then see what the science has come up to see if they think it's the same. Like to ask people, what do you think it was in 1950? What do you think it is now, of the difference? But just a simple way is you can, if you have a sheet metal board, and there's a way to buy them, and you put a piece of sheet on it, then magnets can actually be slid up and down. It's kind of novel. People are used to electronics, but you can slide magnets up and down, and they last a long time, and they work really well, and they're easy to replace, and the whole thing. But you give people a chance to think and guess and play together, and then find out what the science has come up with, and to see that, and then they trying to see, so what did they understand? What was right about the projections, and what do they come and learn about it? I would do another one of wondering, when you come to Earth's temperature and things, of playing to your strength. An aquarium is going to play to its strength. You and the American Museum of Natural History and the places that have done or climate change and not, and those that don't are doing it. But there's, for instance, okay, if we're looking at a period of time when not only is the temperature changing drastically, but it is changing at a rate or in a short period of time that is virtually never happened on the Earth before, or doesn't. When on Earth have there been dramatic temperature changes, either up or down? And what has happened? If we look at now, and we'll come back to that, but then we look back at the KT period, and we look at this period, and we look at this period, you line it up with what went extinct in that period of time. In that few 10,000 years when there's this change, these dinosaurs died out, and that could be models or fossils or models of fossils if you can't afford the fossils. But you see, whenever this happens, huge parts of the Earth's life dies. Species are cut down, they barely survive, others go extinct. Okay, so you see each of these different periods, what they happen. Now you're in this period, and who are you looking at? You're looking in a mirror. And you're looking at the animals and the plants that you love now. Those are what are going extinct now. It's happened over and over on Earth. Every time you have big rapid changes of temperature, this is what happens. I'm just saying it plays to your strength. You have fossils. You're dealing with paleontology. So you can bring out things in ways that are cool and exciting and very tangible that other forms of science education can't do.
Right.
I'm just wondering.
Yeah, and
That's a great point.
Yeah, that's a great point. And one thing that we hadn't planned on talking about today, but I'll mention, is that part of the exhibit will have clams, and clams have annual rings, and fossilized clams have fossilized annual rings that are a pretty good proxy for temperature. And so we will be drawing attention to that and looking at the similarities and differences between layers and ice cores and tree rings and other proxies. So that is a place where that will come into play.
So this is Frank again. One thing I'm looking at the graph is the zero. What average is that zero based on? A full 150 years or subsection thereof, or what?
I believe that's 150 years.
You mean
Yeah.
the general temperature anomaly?
Yeah.
Yeah, it would be good to I mean, I know you don't have all the text here, but I think that's actually a really good point that you should mention that, because some people don't realize that. I mean, it could be the whole 150 records, but also a lot of climatologists will use that moving 30-year record, you know? So that'd be good to sort of clarify that for people on the graph too, and what not only what is the temperature anomaly, but what does zero mean then, and what is it based on? So
Yeah, well, I would be prone to change that zero on the basis of whatever IPCC and UNFCCC is using, because again, that's what's prominent in the news, and that's almost become the motto of the conferences. I think
Yeah,
it's
that's
important.
also what, when they talk about 2 degrees C, you want that to be 2 degrees C relative to your zero on your axis, if you're
Right.
going to use the anomaly.
Yeah, and this 2 degrees C on this is higher than the 2 degrees.
Yeah, I think the zero in here was around 1950 for this, the way these data were put together. But that's a detail that we can finesse, I think.
Yeah, I'd change that to being pre-industrial.
Yeah, that would make sense.
And there's something else I just want to, I think I want to reiterate. I think Anna said this earlier, is that those red bars go all the way down to minus 6 point something, or 0.6 something. And since they are anomalies from zero, I think it's important, if you're going to use the anomalies, that the red bars stop there and that the blues can go down from there to the negative numbers. I just think it sort of implies a lot more warming than is actually there.
yeah, I think that's a good point.
Okay.
I think it's just because you've put sort of two different styles of graphs together here, you know, so you have to just think about the axes. So yeah.
Right. There's a lot of potential for confusion, while at the same time it is visually compelling, but if you start to think about it more, you could get confused, I think. So.
Yeah.
All right. Well, I'm going to move on. Thank you for your comments. I'm going to move on to the next section in the interest of time. So next section is on, and I don't necessarily mean the next section in the exhibit, but the next section we want to talk about with you today, understanding the greenhouse effect. And I think what I'll do is just be silent for about a minute and let you read this text, and then I'll go to the next slide. Okay, I'm going to move on. So the text at bottom right mentions an infrared camera. So the idea is in the exhibit we would have an infrared camera pointing out at visitors and then a monitor displaying what they see. And this is just an example of me in the hallway in our building. So you see me in the infrared, you see me in the visible on the right, but I'm holding this frame which had these 4 panels. And the 4 panels are different materials. There's a dark plastic, a clear plastic. There's one which is just empty, no material, and then there's glass. And so you see some of these materials are transparent in the visible, but not in the infrared, vice versa. Anyway, they have different properties in the infrared and in the visible. So
When you say they're transparent, I mean, some of them are seeing you through it, and some of them are just, the infrared camera is just seeing the temperature of the, whatever the plate is.
right.
Is that right? Yeah.
Yep.
Because what I was because when I looked at your Prezi thing, and the one thing I thought of is, could you put something cold in there, like to represent ice or snow? You'd have to have some power to make it stay cold. But anyway, I think that would be a nice contrast to the rest of them.
Yeah.
Yeah, we actually do have a chunk of ice in the glacier exhibit around the corner.
Yeah.
That's also easy, just freezer ice blocks, because they're cheap and you can just have some that'll last a few hours and you bring out another one. If your eyes clock, that'll bring it down to about 0 degrees, and it'll be just black. It'll be very dark on things. One of the things I think I would highly recommend is be very clear about. You say infrared camera. You're dealing with one type of infrared camera, and the distinctions are extremely important. This is long wave infrared. This is in the basic area where CO2 absorbs infrared, but it's actually picking the window where CO2 doesn't show up. There is a huge amount of confusion right now. Bill Nye just came out with another video online. He gets it all wrong. I mean, and people are insisting that they're telling you how the greenhouse effect works. And when we say infrared, half of the energy from the sun is infrared. So that's incredibly confusing if you don't get that right. If you're doing this, what are we looking at is not that part of infrared. There's these different, you're looking at one part of infrared, and when you break it down for people, you really get them to come home with something really exciting. That this is the part of infrared where this is outgoing energy from the sun that we're looking at here.
So wait a minute, you said outgoing energy from the sun?
I'm sorry, this is outgoing energy from the Earth and the planets.
Right, okay.
Things, and actually, also you want to make clear, this is light I think you do make this clear, this is light that's emitted by the objects themselves. This is not reflected light.
Right. So I just wanted to show you these photos to get you an idea that in the exhibit, if we had this, we would have maybe some kind of flat panel like this with different materials that visitors could slide in front of the infrared camera or something like that. But the details can be worked out. But I just wanted you to get the general idea. And now I'll go to the next slide and I'll ask
This is Wendy. Can I say something real quick on that?
Sure.
I just, you know the scope of your exhibit and where you're putting your energy in, haha, pun not intended. I was just thinking that I had an experience with playing with an infrared camera at a exhibit at the National Geographic Museum here in DC, and I watched a lot of other people interacting with it, and their question about where are you hot and where are you cold, like your text said, was very similar, and they had no panels that could be slipped in between, which seems like a big complication for me. For I'm not sure if it's as much added learning as just them seeing, like, it was very focused on your face and seeing how cool your nose was compared to the flush of your cheeks and forehead. That was powerful enough for people to get the concepts to me. And I'm just not sure how much you gain with a thing that can be damaged or walked off with or broken or whatever. Right. But maybe I'm missing something, but I bet you could simplify it and get many of those same points home.
Okay. Well, maybe I could jump in on that because this is my specialty. I do this for tens of thousands of people, and we pick what we're doing. Absolutely, you want to give some time just for people to look at themselves. There's so much they can do. It connects. Let them have some fun. But glass in particular, plain ordinary glass, you are literally looking at the greenhouse effect. This is not an analogy. It is not something like the greenhouse effect. It is the greenhouse effect. It's just with a solid rather than gases like CO2. You are literally getting to experiment that you can see through the glass, invisible light and shortwave infrared, but long wave infrared is being trapped by the glass. It's being held by the glass and then re-emitted by the glass. You are actually experimenting with the greenhouse effect. There it is. I mean, you want people to, I've had people who are kind of deniers come up and say, God, this is real. That's not really who we're aiming at, but I mean, this is for real. And if you don't believe it, look at it. You get to use the greenhouse effect, not just hear about it.
Yeah. That shows the power of keeping it simple.
So this is Frank. One thing is you got a bridge on here between just simply the sort of playtime of scanning to see where you're hot, where you're cold, and then pulling the panels in front is people who wear glasses.
Right.
I mean, that was the one thing I noticed about the picture that I'm sorry, I forgot your name where you were holding the panels.
Yeah, Ingrid, it's my name.
Yeah, is looking up into your eyes in the FLIR images, and seeing the dark spots. I mean,
Yep.
that's something that could be leveraged in the text of making the transition from sort of the play to find the hot spots and the cold spots to play to find what happens when you put different materials in front of you.
Mhm.
Right.
Okay.
Your eyeglasses are also a demonstration of the greenhouse effect. The energy from your eyes is not getting through the glass.
Yep.
So I guess we've sort of already started talking about some of our questions about this. So maybe let me give you 30 seconds to read the text on this page. All right, unless anyone objects, I'm going to flip to the next slide. Okay, so these are our questions. What does this interactive, as we've described it, help you understand? How does it help you to engage with the content, or not help you? We'd like to hear your pros and cons that you feel.
Well, Jim Callahan, one would be where it's very important is we so often hear in our field right now, we don't need to teach science, or we teach enough, or it's boring, it just doesn't go over. We don't need to teach. Why do we need to have people understand this stuff? I mean, in other words, there's going to be a significant part of our place that are just going to yawn at everything you do, which I totally disagree with. What you're also bringing out at the same time, how the greenhouse effect works, is fundamentals for solutions, for action. If we're going to make buildings more efficient, or lighting, or vehicles, almost all the technological innovations that we're doing use this science that you're getting. If you don't understand this, or you don't have experience with it, you're going to easily be fooled, or your kids are not going to be good engineers or scientists. This is fundamental for taking on global warming, what you're getting right here. So this is really important stuff, I think, that you're bringing out.
Okay.
I agree. The one thing that I think is a little bit difficult to translate is carbon dioxide absorbs the infrared radiation and re-radiates it. And I don't know that your panes of glass are getting at that as explicitly. I mean, I know that we can go through and explain what's happening in terms of absorbing energy from one side and then radiating at its own temperature, but it's not completely obvious. Obviously, when you have the open pane, you're just seeing straight through to the person behind it. The other is it's not. I don't know that you're seeing how those different types of materials are impacting, and I think in that way you can get it solutions to some extent, but I don't know that you're really people being able to understand what's causing the changes from one material to another material.
Hey.
This is Katie. I'm just gonna. I think I like these activities. I think overall it seemed to me like the text was fairly understandable. One thing I'm just going to throw out there, because this is something we used to do at the Exploratorium regularly when developing exhibits, was we'd ask people sort of about the exhibit and their interaction with it in general, but we would specifically also look at the text because, as Wendy pointed out earlier, a lot of us know this content and know these terms and stuff like that. So it might be a good idea to even just get, if you could, like 10 of your visitors kind of to see if any of the text is confusing for them or not. That would be one thing that, like, to me, it doesn't sound confusing. It sounds good, but it might be worthwhile to talk to your actual patrons themselves just to get a sense of that as well. Yeah.
Yeah, and this is Frank again. I'm thinking if I was out um, interviewing visitors, the two questions that probably end up asking them at the tail end of using this exhibit would be, what is the greenhouse effect, and how does the greenhouse effect translate into warmer temperatures? Because I think that last part there, I'm not sure the pieces are all in place to deal with it.
Mm-hmm.
Yeah, so I just want to point out, Don and Ingrid, we have 5 more minutes or so. If there's other questions you want to put before us, and people can continue to respond by emails if we don't have enough time. But I want to just give you the opportunity to bring up anything else you want input on.
Okay. Well, we have multiple ones. Do you want to bring up the next one of the solutions piece, or do you want to skip ahead to something else?
Why don't we go to this solutions
Okay.
piece?
So this is a part of the exhibit where we're talking about solutions to reduce climate change, and we wanted to talk about actions that individuals can take and actions that we can take as a society, and the idea that individual actions are very important, but they're not enough. And one idea we had was to show individual actions was to have sort of a miniature house, maybe a landscape around it, and one could highlight the house of actions related to reducing waste and energy efficiency and so on. And so that's something that we're sort of in the middle of scoping out, and Alex Moore has done a lot of work on that. But the piece that we haven't really thought much about or how to do, other than maybe painting a mural on the wall or the doors, how do we illustrate societal actions? So things like on the list on the right, and again, these are just examples. It's not that we would necessarily put all these in the exhibit, but so we thought we'd throw that out to you. Do you have any ideas of good ways to visually show these types of collective actions? Or
it might be one way you might think about it is, I don't have an explicit answer, but to think about it in terms of just, instead of broadly societal actions, maybe break it into sectors: agricultural, transportation, various kinds of business sectors, and see if you can, because there may be areas in which you then can come up with some kind of collective actions within a sector that you could really have people, interact with. That's just an idea. It's more of a general idea than more specific.
yeah, okay.
Well, this is Frank, and I'm going to throw out a cockamamie idea based on the fact that I was raised on model railroads. And oftentimes I've thought it would be kind of fun to like do a Z or N gauge railroad that would show what local communities would look like if you were at the 100% reduction in emissions by 2100 or 2050. I mean, what would it look like? So it would be kind of like taking drawdown and combining it with model railroads.
Mm-hmm.
Jim Callahan, one with there's the old mantra in science museums is tell me and I'll forget, show me and I'll remember, engage me and I will learn. Is you're a long way there of if you had what we're seeing in this picture with the house, and maybe you either had two houses or have different components of the same house, some with energy efficient or the kind of equipment, the utilities or lights or things that we have that are more energy efficient and the ones that are not, and then let them see it through the long wave infrared camera. Again, you're looking through a long wave infrared camera. That camera will pick out which appliances are efficient and which aren't immediately. You will see them as being efficient or not. It's a way of bringing to light something that people have not seen. Oh, that's why incandescent lights are really crappy. They give off a lot of heat, and you can see that with the camera. But make it a game. Make it something that they can try the different things. Engage them. Let them make the choice in real time and see the effect in real time. We have kids in D.C. who are using these cameras on the White House now. In the next few weeks, they're going to be going down all around Washington, D.C., and putting into the Washington Post with these cameras, look at which buildings are efficient and which are not. So this is action. These are solutions in real time, and you can do it inside the museum.
Mm-hmm.
Any hot spots on the West Wing or not?
That's right. Well, you're gonna see. I mean, in the Clinton era, they did redo the windows in the White House, so we'll see. Have they been, how are they doing? Right? How much? You definitely. I think you'll definitely see some flames on the way. On certain days, you'll see a lot of steam coming out of the West Wing. But that'll come. But I mean, actually, you can do that. You can see how much, because you can't see the Oval Office from the public parts of the place, but you can see other parts and see, gee, why can't I see that person walking around inside the White House? Because the window is the greenhouse effect. But you can see, is the building overall efficient or not? So we're giving people the tools of science so they can be active in making solutions. We're not telling them is like they're going to yawn. Engage them, and they're going to love what you do.
Mm-hmm.
Okay, so we are at the top of the hour, so I'm going to thank Don and Ingrid for their presentation. We hope the input you got is valuable. You're still welcome to put the questions out there to the Clean Network through the email lists if you have further questions.
And I'm just going to throw out there, we still don't have a presentation for next week. If we don't get anybody else, we could continue some of the discussion then as well. So.
Yeah.
Okay. That'd be great.
Very good. All right. Thanks a lot, everybody.
Yep. Thanks all.
All right.
Thank you.
For your email soon.
Bye-bye. Bye.